Hi, today we're going to start a lesson on sequences. Our example in our Use What You Know, the sequence is 7, 10, 13, and 16. And our question is, what is the next number in the sequence? Well, a sequence is basically a list of numbers generated by a pattern. And if you look at it, it might be clear to some of you what is happening, but we are adding 3 each time. So add 3, add 3, add 3, add 3. So you might figure out that the next number would be 19. Now, the problem is I want to get maybe higher and higher numbers. So now maybe what's the 9th number? So some of you guys might go, well, okay, this is, let's see, 1, 2, 3, 4. This is already the 5th number right here. So maybe at this point you realize, well, I only have to do 19 plus 3 more, that would be the 6th number, plus 3 more would be the 7th number, plus 3 more would be the 8th number, and plus 3 more would be the 9th number. Some of you guys also might probably be trying to do this. You probably did 19 plus 3, and that's the 6th number, plus 3 is the 7th number, and plus 3 more is the 8th number, and then plus 3 more is the 9th number. And you might get 31. And that's if we counted right. And that's what makes this so hard. If I want to go to the 14th number, am I going to count right? So we're going to try to figure out a way to figure out the 9th number, maybe not being so, doing it in such a long way. So I'm going to go back, and we're going to go back to the beginning. If we always have a base number we're starting from, like the 7, that's what originally was our first number, we can get every single number from that 7. So, excuse me for my coughing. 7 is the first number. And then if I want to get to the 9th, well, let's see. If I add 3 more, I get to the 2nd number. And I add 3 more, I get to the 3rd number. Add 3 more, I get to the 4th number. Add 3 more, I get to the 5th number. 3 more, I get to the 6th number. 3 more, I get to the 7th number. 3 more, I get to the 8th number. And then 3 more, I get to the 9th number. And I could add this in my calculator, but in math, we're always looking for a way to simplify things. So instead of doing 7 plus 3 plus 3 plus 3, etc., well, let's shorten that. 7 plus. Now, how do I write that I am adding 1, 2, 3, 4, 5, 6, 7, 8 3s in a row? And if I'm adding 8 3s, I can condense that by saying 8 times 3. And that means that there were 8 3s being added to the number 7. And if I do it this way, it just will make life a little easier. And there's our 31 again. So that wasn't so bad. I mean, we could get to 31 easily by keep on adding 3, but this is a great way to get to the number, the 9th term, rather quickly. So again, to get to the 14th, I could keep on adding 3s another 5 times from the previous answer. Or, so I could do 31 and then add 5, or add 3, add 3, add 3, add 3, and add 3. But if we'd use our method that we just did, I know I'm starting at 7. I know I'm going to add 3, and how many 3s am I going to add to get to the 14th? Well, when we did our 9th, we only added 8 numbers. So to get to our 14th, we actually only need to add 13 3s. And the reason it's 1 less is because the first number did not need a 3 to be added to get it. So every time when we go back to the beginning, this was our first, and this is our second. Our second term, we only needed to add 1 3. So you always have 1 less number you're adding than the number of numbers because the first one didn't need 1. So doing it in this fashion, I can get to the 14th one rather quickly now. 7 plus, and then there's going to be 13 3s. So that'll be 46. So when we get to the 100th number, again, trying to add up 3 that many times to get up to the 100th would be really tedious if you try to do it the long way. Although it can be done, I can sit here and keep on adding 3, or I can know that I'm going to start at 7 and I'm going to keep on adding 3s, and the number of 3s I'm going to add is going to be 99. because the first 7 didn't need a 3, and then there's going to be 99 more numbers after that that need a 3 being added to get it. So 304 would be our 100th number in this pattern. So now what we want to do is we want to generate a pattern. And the pattern is, or generate the rule that's going to develop this pattern. And we want to do it in generic terms. So I don't know if I want the 1000th number or the 50th number. So what we say is, what's the rule? We use a sub n to say that the term number you're looking for can be gotten by doing this. All right, and what did we do in our pattern? Well, for all of them, we started at 7. And for all of them, we added 3. And we added 3 so many times. And to figure out how many times we added 3, if you notice the pattern, it was always 1 less than the number you were trying to find. So if the number we're trying to find is n, then we would write n take away 1. That means 1 less 3 than we have numbers. And that is our rule for this particular sequence. All right, let's try the next one. It's going to look very similar, but it's a little different. Okay, so our next one, if you look at the sequence, it's 7, 21, 63, and 189. You could try to see if we're adding 7 to 21, you're adding 14, but 21 to 63 is definitely not adding 14. So if you're not adding the same number, then that's not the sequence we're looking for. So we can also try multiplying. And if we multiply by 3, and we multiply by 3, and we multiply by 3, then that is actually generating our pattern. So we can then figure out that we have to times 3 to get to that next number. And 567 is the next number in our sequence. And again, that is now the 5th number, 1, 2, 3, 4, 5. So again, this is the 5th. If I want to get to the 9th, I can do the same thing I did in the previous problem. I can sit here and go, okay, well, 567 times 3, that would be the 6th number times 3. That would be the 7th number times 3. That would be the 8th number times 3. And that would be the 9th number. But then it's going to get pretty tedious if I want to get to the 20th number. So let's see if we can come up with a rule to help us generate this pattern a lot quicker. So again, we're always going to start with our home base number, 7. 7. And then to get to the 9th, we're going to multiply by 3, multiply by 3. So let's see, that's 1st, 2nd, 3rd. Multiply by 3 is 4th. Multiply by 3 is 5th. Multiply by 3 is 6th. That's 7th. That's 8th. And that's 9th. So I could do that in my calculator, but I want to simplify this because that's too many 3's being multiplied. So how do I simplify that? 7 times, well, how do I write that I'm multiplying 1, 2, 3, 4, 5, 6, 7, 8 3's in a row? Now it's not going to be 3 times 8. 3 times 8 is when I'm adding 8 3's in a row. But now I'm multiplying 8 3's in a row. And to simplify that, that would be 3 to the 8th power. Remember, an 8 power means that there are 3's being multiplied 8 times with each other. So now if I put this in my calculator, we should get the same answer. And we do. So that's just a lot quicker. So now if I want to get to the 14th number, again, I could keep on multiplying by 3, but it gets a little tedious, or I can generate my rule. It's 7 times 3, and the number of 3's I'm going to need to get to the 14th number is 13. Because just like before, the first number 7 did not need a 3. So I needed to multiply 13 more 3's after 7 to get to the 14th number. Now these are going to get rather large quickly. So really big. Okay, so now if we want to get to the 20th number, this is going to be a lot easier now. We start at 7, And now I'm going to multiply 3, and I'm going to have 19 3's in a row being multiplied to 7 to get to the 20th number. Okay, so now our rule. So our rule is kind of similar to the rule previously. We're going to say a sub n. That means that the number term we're looking for, whether it be the 100th term or the 10th term, is equal to, in our particular problem, starting at 7, we multiply 3, and we multiply 3 so many times. And to figure out how many 3's we multiplied, it was always the number we were on minus 1 less. So that would be to the n minus 1 power. Okay, so now we're going to do 2 charts to help you see the pattern again. I have them partially filled out for you on the next 2 pages. And we're going to just do 1 on each page rather than doing all 4. So we'll do the first one on the next page and then skip the bottom one and then go to the 3rd problem. So again, a sequence is just an ordered list of numbers. There's a pattern involved. Each term is called, or each number in the sequence is called a term. So we have the first term is 4, the second term is 7, the third term is 10, the fourth term is 13, the fifth term is 16, and the sixth term is 19. So in our pattern, we have 4 as the beginning initial number, and our first term is 4. To get to the second term, we had to do 4 plus 3, and that gave us the 7. And to get to our third term, again, starting at 4, we did 4 plus 3 and another 3, etc. So now we're just going to show where the pattern is coming from. The first one was 4, and we had to add 0 3's to get to that first term. The second term, we had to do 4 plus 1 3. Now, those were not needed as much, but when we get to the third term, you're going to see why the pattern is coming out. The next one, the third term, we started with 4, and we added 2 3's to get to our third term of 10. Our fourth term, we had 4 plus 3 3's to get to our fourth term, which was 13. Our fifth one, we had 4, and then we had 4 3's to get to our fifth term, which was 16. And then our sixth term, we have 4 plus 5 3's. And now you can kind of see now what's happening with the pattern. The number term we're on and the number of 3's we need, there's 1 less 3 than we need than the number we're on. So when we get to the next one, the 7th, it's going to be 4 plus, well, our 7th term, we're going to need 6 3's. And that's going to come up with a number of 22. All right, now dot, dot, dot. To get to our 9th term, it's going to be 4 plus our 9th term. Then we're going to need 1 less 3, so we're going to need 8 3's. And that's going to come out to be 28. Okay, going to our next one, 15. That's going to be 4 plus, and the number of 3's we're going to need to get to our 15th would be 14. And that's going to be 46. And then our a sub n means to tell me in general, how do you get any term you're looking for? And we started with 4, and we multiplied the number that we're on minus 1 times 3. So this tells you how many 3's you have. You're going to have 1 less 3 than you have numbers. So our 100th one, we would have 99 there. And then we don't do that one. All right, so anytime you're adding a number, and I'm going to skip the bottom chart, but anytime you're adding the same number, it's called an arithmetic sequence, and we're going to do that in our vocab in a sec. So we're going to go to problem 3, which is our sequence generated by multiplying. So our first term is 4 again, but this time we're going to do 4 times 3 to get to our next term of 12. And then we're going to do another times 3 to get to our third term, and etc. So seeing this pattern generated, 4 times 3, none of those. So 3 to the 0. Our second one is 4 times 3 to the 1. There is one of them. Our third one is 4 times 3 times 3, and that's 3 squared if I want to simplify that. Our fourth one is 4 times 3 to the third. Our next one is 4 times 3 to the fourth. And our next one is 4 times 3 to the fifth. So again, keep in mind what number we're on and what the number of 3's we need. So when we were on the 6th, we only needed 5. When we were on the 5th, we only needed 4. So if we want to do the 7th, then we can now figure out the pattern. You're going to have 4 times 3 to the 6th. All right, let's figure that out. Now this one was really easy because I could have just taken 972 and multiplied by 3. Or I can just do my formula, which is 4 times 3 to the power 6. And it's going to give us our same number. Okay, so moving on to the 9th term now. The 9th term, we know it's going to be 4. And after that, to get to the 9th, we're going to need 8 more 3's. So that's going to be 3 to the 8th power. Because again, we're multiplying 8 3's in a row. All right, so 26,244. All right, our 12th one is going to be 4 times, to get to our 12th, we're going to have 11 3's in a row, so it's going to be 3 to the 11th power. So these grow really fast, these times 1. And then finally, our formula, our A sub n. A sub n, 4 times 3, and the number of 3's we're going to have is 1 less than the number of numbers, so n minus 1 power. So anytime we are multiplying the same number, it's called the geometric. And again, we're not going to do the bottom chart for the sake of time, but multiplying the same number means geometric. Okay, so now we're going to do our 2 pages of notes. I blocked off the definitions. So we have a sequence. So a sequence is just an ordered list of numbers. All right, I'll just move it out of the way for a sec. So it's an ordered list of numbers that follows a pattern. And pause at any time if you need to need more time to write them out. A term is each number in the sequence is called a term. So each number in the sequence is a term. The first term, the second term, the fourth term, etc. Now, an arithmetic sequence is a special type of sequence. An arithmetic that I already talked about is when you are generating the sequence by adding the same number each time to get to the next term. So a sequence in which the same number is added to a term to get to the next term. Now, the number that you're adding over and over again, that has a special name, and that's called the common difference. So the common difference is the name of that special number that's being added in an arithmetic sequence over and over and over. A geometric sequence is our other special type of sequence, and you can probably figure that out. A geometric is a sequence in which the same number is being multiplied to a term to get to the next term. So when you hear arithmetic, you have to know that the pattern is generated by adding, and when you hear geometric sequence, you have to realize that the sequence is being generated by multiplying the same number. And that number that you keep on multiplying over and over again, that has a special name as well, and that's called the common ratio. So the common ratio is the number that is being multiplied in a geometric sequence to get to the next terms. Okay, so for each of the types below our questions, I want you to tell me if it's an arithmetic, geometric, or neither. And then if it is an arithmetic, tell me the common difference. And if it is a geometric, tell me the common ratio. All right, so you can pause it and try to figure these out first. Problem number 1, 4, 14, 24, and 34. Some of them are going to jump out really obvious, and some of them are not going to be as obvious. This one looks really clear that we're adding 10, and we're adding 10, and we're adding another 10. So that's the same number. So this is an adding sequence, so this is arithmetic. And because you're adding the same number, and that number, that common difference, is the special name, equals 10. Now the number that you're adding doesn't have to be a whole number. It doesn't even have to be positive. You can add a negative number, you can add a fraction, you can add a decimal. Okay, top right, we'll do this one next. So 5, 20, 80, and 320. Well, if you add 15 to get to 20, you're adding 60 to get to the next number. So that is definitely not arithmetic. So you can try geometric, times 4 to get to 20, times 4 to get to 80, times 4 to get to 320. That works. So since we're multiplying, this is geometric. And your common ratio is 4. Okay, well, 6 to 11, let's see. We have plus 5. Okay, but then 11 to 17 is actually plus 6. And 17 to 24 is actually plus 7. So it's not adding the same number. So it's not arithmetic. Geometric, if I have to multiply some number to get to 6 to 11, I could try. And in order to figure out what that would be, you would divide 11 divided by 6. Is that really awful number? But then I have to make sure 17 divided by 11 is the same thing. And it's not. So this is not added or subtracting. So this would be neither. It is a sequence. It's just not our arithmetic or geometric one. Okay, so for the next one. Sometimes, like I said, they're not obvious. So if you ever want to find the common difference, you would subtract a term with the one before it. And if you want to find a common ratio, if it's not so obvious, you would divide a term with the one before it. I should say the term before it. Okay, so again, if I really want to check this, I could try taking this number and subtracting off that number, but then I have to double check and do another pair and make sure that those also are the same. All right, so negative 24 minus 16. But now I have to check, does 36 minus negative 24 also give me the same common difference? It does not. So it can't be an arithmetic. Let's try geometric. I have to divide. You can either use the fraction key or you can use the division sign. Does not matter. So it's always the term divided or subtracted by the term before it. So negative 24 divided by 16. So now we're trying dividing. And that gives us negative 3/2. And then I got to try the next pair to make sure it's the same. 36. And then the one before it is negative 24. And that's also negative 3/2. So that means that this is a geometric. We have a common difference, or sorry, common ratio of negative 3/2. Now, you could also use negative 1.5 if you would rather work with a decimal rather than a fraction. That is fine. Okay, so after you determine what it is, arithmetic, geometric, etc., now you might be asked to find certain term numbers. So our B question is just the same. This one, and this one are the same three problems, but I changed this one so that it could be actually one that we could use. All right, so the first one, top left, 4, 14, and 24 from our previous page. We already know that it's arithmetic because we were adding 10. So if I want to find the 50th term using our patterns we generated from the previous exercises we did, we know we can start with our home base number 4. And we know to get to the 50th term, we're going to add 10, and we're going to add 10 49 times. So it's going to be 49 tens that we're going to need to add to 4 to get all the way up to the 50th. That's a lot better than actually doing it one by one on our calculator. All right, so if you put that in your calculator, you'll get 494 will be the 50th term in this sequence. So now to write a formula for a sub n, that means to find any number we want, this is the pattern we're doing. We're doing 4 plus the number of tens I'm going to need is always going to be 1 less 10 than we have numbers. So that means n minus 1. That's what n minus 1 means, 1 less 10 than we have numbers. And we're going to do that. We're going to add 10 that many times. So there's our formula to generate this pattern. All right, top right. From the previous page, we know that this is times 4. So what's the 15th term? Again, starting from our home base number, 5. We know that we're going to do times 4 times 4 times 4. And we're going to do times 4. Well, if we have 15 numbers, we know we're going to have 14 4s being multiplied. So that would be 4 to the 14th power. So pretty big number. So generating our pattern, we know our a sub n formula you get by doing 5 times 4, and then it's to the n minus 1 power. 1 less 4 than you have numbers. Okay, so for the new one, what's going on? Well, 13 to get to 5, you're subtracting 8. 5 to get down to negative 3, you're also subtracting 8. If you did not know that, we could always do our subtractions to make sure. You always take the term and you minus off the one before it. So it's not going to be high number minus low number. So there's our minus 8. And just to double check, negative 3 and then minus off the term 5 before it is also negative 8. So it is subtracting off negative 8. So because we're doing negative 8 each time, that is actually adding negative 8. So this is an arithmetic. So the 100th term, our home base number is 13. And from 13, we're going to add a negative 8. Now you can write plus a negative 8 like this. Most of the time, though, if you see it on a multiple choice, we'll just show it as a minus 8. And we're going to minus 8 how many times? Well, there's 100 numbers. We know that that means there's going to be 99 more 8s after the first one. Okay, so 13 minus 8, 99 times. Yes, and you can interchange these two numbers. If you want to write 99 8s or 8 99s, that's fine. A multiplication can be reversed. So the 100th number is negative 779. So our formula, a sub n equals, we start with 13, and we minus off 8, n minus 1 times. Or again, reverse, n minus 1 times 8. All right, and our last one. Our last problem from our previous page, we know that it was arithmetic, or geometric, excuse me, and that turned out to be negative 3/2 or negative 1.5, your choice. So what's the sixth term? So I know from my home base number is 16, you're going to multiply negative 3/2, and you're going to multiply that number 5 times from the home base number. One less than you have numbers. Decimal or fraction is fine. I'm just going to go with a fraction. Okay, so you can either have this answer or the decimal equivalent. So whichever answer you want. All right, and lastly, our formula is a sub n. We started with 16. We know we're going to multiply negative 3/2, and the number of times we're going to multiply that is always 1 less than the number of numbers. So n minus 1 power.